အားလုံးပဲမင်္ဂလာပါအခုကတော့ထုံးစံအတိုင်းသင်္ချာနဲ့ပတ်သက်တာလုပ်ကြမယ်ပေါ့နော်ဒီမှာအဲ့ဆိုအရင်ပတ်တွေကအထူးသဖြင့်ဒီ vector နဲ့ဒီ vector linear algebra မှာအဓိကအရေးပါတယ် vector တွေ matrix တွေကြောင်းပြန်ပြီးလေ့လာနေကြတယ်ပေါ့နော်တော်တော်များဆိုရင်ဒီဟာလေး topic တော်တော်များလဲဆိုကာပါတော့လုပ်ပြီးသွားပြီပေါ့ဒါပေမဲ့တချို့ဟာလေးလည်းကြံပါသေးတယ်လို့ဆိုတော့လေကြည့်ရအောင်ပေါ့နော်အဲ့ဆိုဘယ်ထိပြီးသွားပြီလဲဆိုတော့ဒီ cross product နဲ့ cross product relationship ကဘာဖြစ်လဲဆိုတဲ့အကြောင်းလည်းဆိုကြည့်ပြီးသွားပြီပေါ့နော်ဒီမှာ dot product ကဘာကိုပြောတာလဲ dot product ကဘာကိုညှောင်းလိုက်ဘာကိုထွက်လာလဲဆိုတဲ့ဟာလေးရယ် cross product ကြတော့ဘာကိုထွက်လာပေးလဲဟာလဲဆိုတဲ့ဟာလေးပေါ့နော်ကြက်တော့မှတ်မိတာ dot product ကဘာထွက်လာလဲသူကလုတ်လိုက်ရင်လေဘာထွက်လာလဲ dot product လို့ဘာထွက်လဲ cross product ဘာထွက်လာလဲ okay cross product လည်းရော
vector
အဲ့နှစ်ခုပေါ့နော်အဲ့ဒါလေးနည်းမှတ်ပေါ့အခုလို့ဆိုသူရဲ့သူတို့ဒီ dot product နဲ့ cross product ရဲ့ comparison လေးကိုလည်းဆိုပြန်ကြည့်ကြမယ်ပေါ့နော်ဒီဟာလေးနဲ့ပတ်သက်ပြီးတော့ okay let's see
for several videos now that the dot product of two non-zero vectors a and b is equal to the length of vector a times the length of vector b times the cosine of the angle between them. And the angle between them, let me draw a and b just to make it clear. If that's my vector a and that's my vector b right there, the angle between them is this angle. And we defined it in this way. And actually, if you ever want to solve, if you have two vectors and you want to solve for that angle, and I've never done this before explicitly, and I thought, well, I might as well do it right now, you could just solve for your theta. So it would be a dot b divided by the lengths of your two vectors multiplied by each other is equal to the cosine of theta, and then to solve for theta, you would have to take the inverse cosine of both sides, or the arc cosine of both sides, and you would get theta is equal to arc cosine of a dot b over the magnitudes or the lengths of the products of, or the lengths of each of those vectors multiplied by each other. So if I give you two arbitrary vectors, and the neat thing about it is this might be pretty straightforward. If I just drew something in 2 dimensions right here, you could just take your protractor out and measure this angle. But if a and b each have 100 components, it becomes hard to visualize the idea of an angle between the two vectors. But you don't need to visualize them anymore because you just have to calculate this thing right here. You just have to calculate this value right there. And then go to your calculator and then type in arc cosine or the inverse cosine. They're the equivalent functions. And then it'll give you an angle. And that, by definition, is the angle between those two vectors, which is a very neat concept. And then you can start addressing issues of perpendicularity and whatever else. Well, this was a bit of a tangent. But the other outcome that I painstakingly proved to you in the previous video was that the length of the cross product of two vectors is equal to, it's a very similar expression, it's equal to the product of the two vectors' lengths, so the length of A times the length of B, times the sine of the angle between them, times the sine of the angle between them. So it's the same angle. So what I want to do is take these two ideas, and this was a bit of a diversion there, just to kind of show you how to solve for theta, because I realized I've never done that for you before. But what I want to do is I want to take this expression up here and this expression up here and see if we can develop an intuition, at least in R3, because right now we've only defined our cross product, or the cross product of two vectors is only defined in R3. Let's take these two ideas in R3 and see if we can develop an intuition. And I've done a very similar video in the physics playlist where I compared the dot product to the cross product. Now, if I'm talking about, let me redraw my vectors. So the length of A, so let me draw A, B, I want to do it bigger than that, so we do it like that. So that is my vector B, so this is B, that is A. What is the length of A times the length of B times the cosine of the angle? So let me do that right there. So this is the angle. So the length of A, if I were to draw these vectors, is this length right here. This is the length of A. It's this distance right here, the way I've drawn this vector. So this is literally the length of vector A. And I'm doing it in R3, or maybe a version of it that I can fit onto my little blackboard right here. So it'll just be the length of this line right there. And then the length of B is the length of that line right there. Is the length of that line right there. So that is the length of B. So what is, let me rewrite this thing up here. Let me write it as B, the length of B, times the length, I want to be careful, I don't want to do the dot there because you'll think it's a dot product, times A cosine of theta. All I did is I rearranged this thing here. It's the same thing as A dot B. Well, what is A times the cosine of theta? Let's get out our basic trigonometry tools. SOHCAHTOA. SOHCAHTOA. Cosine of theta is equal to adjacent over hypotenuse. So if I create a right triangle here, and let me introduce some new colors just to ease the monotony. If I drop a right triangle right here, and I create a right triangle right there, and this is theta, then what is the cosine of theta? It's equal to this, let me do it in another color. It's equal to this, the adjacent side, it's equal to this little magenta thing, not all of B, just this part that goes up to my right angle. That's my adjacent. Now I want to do a little bit bigger. It's equal to the adjacent side over the hypotenuse, right? So let me write this down. So cosine of theta is equal to this little adjacent side. I'm just going to write it like that. Is equal to this adjacent side. It's not a nice adjacent side over the hypotenuse. But what is the hypotenuse? It is the length of vector A. It's this. That's my hypotenuse right there. So my hypotenuse is the length of vector A. And so if I multiply both sides by the length of vector A, I get the length of vector A times the cosine of theta is equal to the adjacent side. I'll do that in magenta. Is equal to the adjacent side. So this expression right here, which was just A dot B, can be rewritten as, I just told you that the length of vector A times cosine of theta is equal to this little magenta adjacent side. So this is equal to the adjacent side. So you can view A dot B as being equal to the length of vector B, that length, times that adjacent side. And you're saying, Sal, what does that do for me? Well, what it tells you is you're multiplying essentially the length of vector B times the amount of vector A that's going in the same direction as vector B, right? You can kind of view this as the shadow of vector A, and I'll talk about projections in the future, and I'll more formally define them, but if the word projection helps you, just you think of it that word. If you have a light that shines down from above, this adjacent side is kind of like the shadow of A onto vector B. And you can imagine if these two vectors, if our two vectors looked more like, if they looked more like this, if they were really going in the same direction, let's say that's vector A and that's vector B, then the adjacent side that I care about is they're going to have a lot more in common. The part of A that is going in the same direction of B will be a lot larger. So this will have a larger dot product. Because a dot product is essentially saying how much of those vectors are going in the same direction, but it's just a number. So it'll just be this adjacent side times the length of B. And what if I had vectors that are pretty perpendicular to each other? So what if I had two vectors that were like this? What if my vector A looked like that, vector A looked like that, and my vector B looked like that? Well, now the adjacent, the way I define it here, if I had to make a right triangle like that, the adjacent side's very small. So your dot product, even though A is still a reasonably large vector, is now much smaller because A and B have very little commonality in the same direction. And you could do it the other way. You could draw this down like that, and you could do the adjacent the other way, but it doesn't matter because these A's and B's are arbitrary. So the takeaway is the fact that A dot B is equal to the lengths of each of those times the cosine of theta To me, it says that the dot product, so the dot product tells me how much are my vectors moving together, or the product of the part of the vectors that are moving together. Product of the lengths of the vectors that are moving together or in the same direction. Same direction, right? You could view this adjacent side, here as the part of A that's going in the direction of B, right? That's the part of A that's going in the direction of B. So you're multiplying that times B itself. So that's what the dot product is. How much are two things going in the same direction? And notice, when two things are orthogonal, or when they're perpendicular, when A dot B is equal to 0, we say they're perpendicular. And that makes complete sense based on this kind of intuition of what the dot product is doing, because that means that they're perfectly perpendicular. So that's B, and that's A. And so the adjacent part of A, if I had to draw a right triangle, it would come straight down. And if I were to say the projection of A, and I haven't drawn that, or if I put a light shining down from above, and I'd say what's the shadow of A onto B, you'd get nothing. You'd get 0. This arrow has no width, even though I've drawn it to have some width. It has no width. So you'd have a 0 down here, the part of A that goes in the same direction as B. No part of this vector goes in the same direction as this vector. So you're going to have this 0 kind of adjacent side times B, so you're going to get something that's 0. So hopefully that makes a little sense. Now let's think about the cross product. The cross product tells us, well, the length of A cross B, I painstakingly showed you, is equal to the length of A times the length of B times the sine of the angle between them. So let me do the same example. Let me draw my two vectors. That's my vector A. This is my vector B. And now sine, SOHCAHTOA. So sine of theta, let me write that. Sine of theta, SOHCAHTOA, is equal to opposite over the hypotenuse. So if I were to draw a little right triangle here, so if I were to draw a perpendicular right there, and this is theta, what is the sine of theta equal to in this context? The sine of theta is equal to what? It's equal to this side over here. Let me call that just the opposite. It's equal to the opposite side over the hypotenuse. So the hypotenuse is the length of this vector A right there. It's the length of this vector A. So the hypotenuse is the length over my vector A. So if I multiply both sides of this by my length of vector A, I get the length of vector A times the sine of theta is equal to the opposite side. So if we rearrange this a little bit, I can rewrite this as equal to, I'm just going to swap them. I have to do it with the dot product as well. This is equal to B, the length of vector B times the length of vector A, sine of theta. Well, this thing is just the opposite side, as I've defined it right here. So this right here is just the opposite side, this side right there. So when we're taking the cross product, we're essentially multiplying the length of vector B times the part of A that's going perpendicular to B, right? This opposite side is the part of A that's going perpendicular to B. So they're kind of opposite ideas. The dot product, you're multiplying the part of A that's going in the same direction as B with B, while when you're taking the cross product, you're multiplying the part of A that's going in the perpendicular direction to B with the length of B. So you're saying, it's a measure, especially when you take the length of this, it's a measure of how perpendicular these two guys are. And it's a measure of how much do they move in the same direction. And let's just look at a couple of examples. So if you take two right triangles, so that that's A and or if you take two vectors that are perpendicular to each other, the length of A cross B is going to be equal to, we just use this formula right there, the length of A times the length of B. And what's the sine of 90 degrees? It's 1. So in this case, you kind of have maximized the length of your cross product. This is as high as it can go, because sine of theta, its maximum value, sine of theta is always less than or equal to 1. So this is as good as you're ever going to get. This is the highest possible value when you have perfectly perpendicular vectors. Now, when is, actually just to kind of go back to make the same point here, when do you get the maximum value for your cosine for your dot product? Well, it's when your two vectors are collinear. If I have one vector, if my vector A looks like that and my vector B is essentially another vector that's going in the same direction, then theta is 0. There's no angle between them. And then you have A dot B is equal to the magnitude or the length of vector A times the length of vector B times the cosine of the angle between them. The cosine of the angle between them, that cosine of that angle is 0, or the cosine of the angle is 0, so the cosine of that is 1. So when you have two vectors that go exactly in the same direction, or they're collinear, you kind of maximize your dot product. You maximize your cross product when they're perfectly perpendicular to each other. And just to make the analogy clear, when they're perpendicular to each other, you've minimized, or at least the magnitude of your dot product. You can get negative dot products, but the absolute size of your dot product, the absolute value of your dot product is minimized when they're perpendicular to each other. Similarly, if you were to take two vectors that are collinear, and they're moving in the same direction. So if that's vector A, and then I have vector B that just is another vector that I don't want to draw them on top of each other, but I think you get the idea. Let's say vector B is like that, vector B, then then theta is 0. You can't even see it. It's been squeezed out. I've just brought these two things on top of each other. And then the cross product in this situation, A cross B, is equal to, well, the length of both of these things times the sine of theta. Sine of 0 is 0, so it's just 0. So two collinear vectors, the magnitude of their cross product is 0, but the magnitude of their dot product, the A dot B, is going to be maximized. It's going to be as high as you can get. It's going to be the length of A times the length of B. Now, the opposite scenario is right here. When they're perpendicular to each other, the cross product is maximized because it's measuring on how much of the perpendicular part of A is multiplying that times the length of B. And then when you have two orthogonal vectors, your dot product is minimized, or the absolute value of your dot product. So A dot B in this case is equal to 0. Anyway, I wanted to make all of this clear because, sometimes you kind of get into the formulas and the definitions and you lose the intuition about what are all of these ideas really for. And actually, before I move on, let me just make another kind of idea about what the cross product can be interpreted as. Because a cross product tends to give people more trouble. So if I have, that's my A, and that's my B, what if I wanted to figure out the area of this parallelogram? So if I were to shift A and have that there, and if I were to shift B and or draw a line parallel to B, and if I wanted to figure out the area of this parallelogram right there, how would I do it just using regular geometry? Well, I would drop a perpendicular right there. I would drop a perpendicular right there. If this is perpendicular and this length is h, let me see, for height, then the area of the parallelogram is just equal to the length of my base, which is just the length of vector B, times my height, Well, what is my height? Well, let me just draw a little theta there. Let me do a green theta, it's more visible. So theta. So we know already that the sine of this theta is equal to the opposite over the hypotenuse. So it's equal to the height over the hypotenuse. The hypotenuse is just the length of vector A. So it's just the length of vector A. Or we could just solve for height. We get the height is equal to the length of vector A times the sine of theta. So I can rewrite this here. I can replace it with that. And I get the area of this parallelogram is equal to the length of vector B times the length of vector A sine theta. Well, this is just the length of the cross product of the two vectors, A cross B. This is the same thing. I mean, you can rearrange the A and the B, so we now have another way of thinking about what the cross product is. The cross product of two vectors or at least the magnitude or the length of the cross product of two vectors. Obviously, the cross product, you're going to get a third vector, but the length of that third vector is equal to the area of the parallelogram that's defined, or that's kind of, that you can create from those two vectors. Anyway, hopefully you found this a little bit intuitive, and it'll give you a little bit more of kind of a sense of what the dot product and cross product are all about.
ဟုတ်ပါပြီဒါလေးပြီးသွားကြပြီလားခင်ဗျာပြီးသွားပြီလားဒီကလေးတော်တော်လေးတော့ရှင်းစာပြသွားတယ်ပေါ့နော်ဒီက theory လေးသူပြောရတယ်ပေါ့နော်သဘောကျလား dot product ကဒီသူ graph လေးဆွဲပြသွားပါရလားဒီနေရာလေးကိုလေဒီ dot product
length the other way, but it doesn't
dot product နဲ့ဒီသူဆွဲပြသွားတယ်အဲ့ဒါဆိုဒီ projection နဲ့ပတ်သက်တာလေးနဲ့ခေါင်းစားနေကြပါရောလားအရင် machine learning course မှာလေ course မှာတော့ဒီ projection တွေဘယ်လိုဖြစ်နေလဲဗာလဲပြဿနာဒီဟာဒီသူကဒီ science ဆိုတဲ့သဘောနဲ့ပြောတဲ့ပုံစံမျိုးလေးပေါ့နော် ဒီ projection နဲ့ပတ်သက်တာအဲ့ course မှာတော့အဲ့လိုဆိုတော့ဒီမှာဆိုရင်တင်ပေါ်လေးသူမျက်စိနဲ့ရှင်းသွားတဲ့ပုံစံလေးတို့ပြတယ်ပေါ့နော်အဓိကဒီ dot product ရဲ့ reasoning ပါမယ်ပြီးသွားတော့သူပြောဒီဟာလေးကိုလည်းပြုံးနေကြည့်လိုက်ရင်ဘာမှမသိဘူးသူဆိုနေတာပဲဒီမျိုးသူက shortcut ပုံစံမျိုးလေးထင်တယ်သူပြောတယ် so code တို့ဆိုတော့ဘယ်ဟွာလဲဆွေးတယ်တစ်ချက်ဒီမှာသူရေးထားပါရလားဒီမှာလေးကြီးတစ်ချက်နားလေးနော်သူရေးထားတဲ့ဟာလေးလည်းပြန်ပြပေးပေါ်ရင်းနဲ့ရောက်သွားပြီထင်တယ်ဒါလေးအဲ့ဒါကြောင်ရတယ်ဖထမဆုံးတွေဘာလဲပြောချင်တော့ formula လေးပြောချင်တာပေါ့နော်ဒီ adjacent ကဒါ adjacent ပြောတာ hypotenuse လို့ပြောချင်တာဒီမှာဆိုရင်ဒါ opposite ပေါ့နော်မျိုးဟာလေးပြောချင်တာမျက်စိနဲ့မြင်အောင်လို့ဒီဟာလေးကိုသူဆို s ဆိုရင်ဒါ sin ပေါ့နော် cos ဒီဟာ tangent x မမအောင်ဆိုရင် tangent လို့ထင်တယ်ပေါ့နော်ဒီဟာ sin cos tangent သူဒီမှာဆို cos formula ဆိုရင်သူက adjacent ဒီဟာဆိုရင် h ပေါ့နော် hypotenuse ပုံစံမျိုးသုံးထားတဲ့ပုံစံမျိုးဒီဟာလေးပေါ့ adjacent divide by hypotenuse ဒီမှာဆိုရင်ဒါ o ဖြစ်တဲ့ opposite divide by hypotenuse ဖြစ်တဲ့ဒီဟာပေါ့နော်ဒီမျိုးပုံစံမျိုးတွက်ထားတဲ့ပုံစံမျိုးဒီဟာလေးကို s မအောင်ဆိုရင်ဒီ cos theta ကိုရှာတဲ့ဟာ sin theta ကိုရှာတဲ့ဟာ cos theta ကိုရှာတဲ့ဟာ tangent theta ကိုရှာတဲ့ဟာ formula လေးပေါ့နော်အတူကောက်လေးခုနအဲ့ဒါကြည့်နေပါလဲဘာသူဘယ်သူမှမစုံနေလဲပေါ့ဟုတ်ကဲ့ပါဒါပါဒီကဒီမှာသူပြောတာဒီနေရာလေးပေါ့နော်ဒီခုန dot product ကိုပဲလဲဆိုတော့ဘာလို့ရှာလဲပေါ့နော် reasoning ကိုပြောချင် equation ပေါ့နော်ဒီမှာဆိုရင်ဒီသူရဲ့ဒီ dot product ရဲ့အဓိကကဲဟာဒီ beta နှစ်ခုကသူတို့ same direction မှာဘလောက်တူသွားနေလဲပေါ့နော် how much do things going to the same direction နဲ့ပြောသွားတယ်ဆိုတော့ဖြစ်တဲ့အတွက်ပေါ့နော်ဒီ beta နှစ်ခုကသူ့ရဲ့ magnitude တူဖြစ်တဲ့ဟာမျိုးသူဘယ်လိုသွားနေလဲဆိုတဲ့အကြောင်းလေးနည်းနည်းပြောသွားတယ်ပေါ့နော်ဒါလေး Alex နည်းနည်းလေးပို့ပြီးတော့နားလည်လာတာပေါ့နော်ဒီဟာလေးကိုနားထောင်ပြီးတော့ dot product နဲ့ပတ်သက်တာလေးမောင်လေးတို့ကပဲအဲ့ဒီဟာနဲ့ပတ်သက်ဘယ်လိုနားလဲတယောက်တော့ပြောကြည့်ပါအောင်ကိုပြောပါအောင်
dot product ကလေအမဟိုသူကvector A နဲ့ B ကdirection တူတူပဲသွားနေရင်သူကတန်ဖိုးအများဆုံးရနိုင်မယ်။ဘာဖြစ်လို့လဲဆိုတော့ dot က cos ကို cos 0ဆိုရင်1ဆိုရင် length A နဲ့ B မြောက် length ပဲရှိမယ်ဗျာ။ဟုတ်အဲ့တော့အများဆုံးနည်းနည်းလေး down လေးရှိလာနဲ့ cos ရဲ့ဟာကရော့သွားတယ် cos တန်ဖိုးကcos 90ဆိုရင်
cos 90ဆိုရင်1ဆိုတော့သူက less than 1ဖြစ်တဲ့အတွက်သူက
cos 90တောင်းရော့တောင်းတေးဝါနဲ့cos 90ဆို0လေမှာအဲ့တော့တောင်းကကျဲဝါတော့ direction ကအပေါ်နဲ့ base ဖြစ်သွားမတူတော့အဲ့ဆိုရင် cos 90ဆိုရင်0ဆိုတော့သူက direction မတူတာနဲ့အမျှတန်ဖိုးကနည်းနည်းဝါပေါ့
သူတို့တရားစိတ်နာရှင်မသွားတာပုံစံမျိုးသူကမျက်စိမြင်ရမယ်ဆိုရင် cos ကလည်းကိုဒီ cos theta value ဒါလုံးဝ0ဆိုရင်ပေါ့နော်ပြောချင်တာတို့နှစ်ခုက overlap ဖြစ်နေတဲ့ပုံစံမျိုးလေးပေါ့နော်ဒီလိုမျိုးတစ်ခုနဲ့တစ်ခုကြောင်းမှရှိနေတယ်လို့က0မဟုတ်ပါနဲ့ဒီ theta တန်ဖိုးကလည်း90ပုံစံမျိုးမျက်စိမြင်လိုက်ပေါ့နော်ဒီလို45 90 180လို့ပုံစံမျိုးလားဘာမှဒီစလုံးဝ opposite direction ကိုဖြစ်သွားရဟုတ်တယ်ဟုတ်အဲ့လိုမျိုးလေးပေါ့နော်အဲ့လိုမျိုးဆိုရင်ဒါခုနသူ့ရဲ့ဒီ magnitude နဲ့ဆိုတော့ direction တူမသွားတော့ဆိုသဘောပြောတဲ့ပုံစံမျိုးလေးပေါ့နော်ဟုတ်ပါပြီသူစင်ပါတယ်ဒီ cross နဲ့ပတ်သက်တာကိုသူပြောချင်နေလဲသူပြောမှလည်းငြိမ်သွားတယ်ပေါ့မနေ့ကြောက်သူပြောမှလည်းနည်းနည်း cross နဲ့ပတ်သက်တာလေးမျက်စိတွေဘယ်လိုလေးကိုနားလိုက်တယ်ဒီဗီဒီယိုကြည့်တော့ပေါ့နော်
ရတယ်မှာပြော
ကြားပြော
ဟုတ်မှာဟာဒီ crop မှာကျွန်တော်စနပဲကိုပြောလို့ပဲလေကျွန်တော် polylinear ဖြစ်မယ်ဆိုရင်ကျွန်တော်တို့ရဲ့ corporate ကြီးကလုံးဝ minimize ပေါ့နော်လုံးဝ0ဖြစ်သွားပြီ ဘာလို့လဲဆိုတော့ကျွန်တော်က sin နဲ့သူက crop ရဲ့ formula မှာ sin ပါတယ်လေsin တိဟာဆိုတော့ sin 0ဆိုရင်ကျွန်တော်တို့တွက်ကြည့် sin 0ကြီးက0ဖြစ်သွားရတာကျွန်တော်တို့ပဒါနှစ်ခုက collinear ဖြစ်မယ်ဆိုရင် crop product မှာလုံးဝ0သူကနောက်တစ်ခု crop ကိုထပ်ပြောသွားတာကကျွန်တော် crop product ဆိုလို့ရှိရင်ကျွန်တော်တို့ပဒါနှစ်ခုရဲ့ area ကိုပါရှာလို့ရတယ်ဆိုလို့သူကတက်ပြသွားတယ် crop အဲ့လောက်ပဲသူအဓိကသူပြောချင်တာကဒီမှာသူက projection ကိုနည်းနည်းသူကပို့ပြီးတော့ integration လုပ်ချင်တာပဲပုံစံပေါက်တယ်ကျွန်တော်စနာပြောလို့ပဲပဒါနှစ်ခုရဲ့ drop product ပေါ့နော် drop product က0ဖြစ်မယ်ဆိုရင်ကျွန်တော်တို့ဘာသာနဲ့က orthogonal ပေါ့ orthogonal ဆို90 90ကြာသွားတဲ့အချိန်မှာကျွန်တော်ရဲ့ projection no projection ဖြစ်သွားတယ်အဓိကတော့အဲ့ဒါကိုပြောချင်တာဒီမှာကျွန်တော်ထင်တော့
ဟုတ်တယ်အဲ့
ဒါမှကျွန်တော်တော့
ဒီဟာနဲ့ပတ်သက်လဲဆိုတော့ဒီ machine learning course မှာသတိထားမိတာဒီ projection နဲ့ပတ်သက်တာဟာပေါ့နော်ဒီ beta နှစ်ခုက same direction မှာသွားနေလားသူတို့တယောက် project ဘယ်လိုရှိနေမလဲအဲ့ဒါနဲ့ပတ်သက်တာလေးပို့ပြီးတော့မျက်စိနဲ့မြင်လာကြမယ်ခဏပဲဟုတ်ပါပြီကျေးဇူးတင်ပါတယ်မောင်လေးတို့နောက်တစ်ခုသွားအောင်နော်နောက်တစ်ခုကဘာလဲလဲကြည့်အောင်နောက်တစ်ခုက electro ပါပြီးသွားပြီလဲဆိုတော့က okay ဒီဟာလေးပြီးသွားပြီပေါ့နော်ဒီဟာထားလိုက်ပါလဲ skip လုပ်လိုက်မယ်နည်းနည်း expansion တွေဆိုတာဒီဟာလေးတော့ကြည့်အောင်နော် normal beta from plane equation ဆို normal equation မင်းညပြောတာဒါများလားမသိကြည့်အောင်
This video is make sure that we're good at picking out what the normal vector to a plane is if we are given the equation for a plane. So to understand that, let's just start off with some plane here. Let's just start off, so this is a plane, I'm drawing part of it, obviously it keeps going in every direction. So let's say that that is our plane, and let's say that this is a normal vector to the plane. So that is our normal vector to the plane. It's given by AI plus BJ plus CK. So that is a normal vector to the plane. And let's say that we have, so it's perpendicular to every other vector that's on the plane. And let's say we have some point on the plane. We have some point, it's the point X sub P, I'll say P for plane, so it's a point on the plane, XP, YP, ZP. If we pick the origin, so let's say that our axes are here. So let me draw our coordinate axes. So let's say our coordinate axes look like that. This is our z-axis. This is, let's say that's a y-axis, and let's say that this is our x-axis. Let's say this is our x-axis coming out like this. This is our x-axis. You could specify this as a position vector. There is a position vector. Let me draw it like this. Then it would be behind the plane right over there. You have a position vector. That position vector would be xpi plus ypj plus zpk. It specifies this coordinate right here that sits on the plane. Let me just call that something. Let me call that position vector, I don't know, let me call that P1. So this is a point on the plane. So it is P1 and it is equal to this. Now, we could take another point on the plane. Let's say we're taking, this is a particular point on the plane. Let's say we just say any other point on the plane, X, Y, Z, but we're saying that X, Y, Z sits on the plane. So let's say we take this point right over here, X, Y, Z. That clearly, same logic, can be specified by another position vector. We could have a position vector that looks like this, and dotted line. It's going under the plane right over here. And this position vector, I don't know, let me just call it P, instead of that particular, that P1. This would just be XI plus YJ plus ZK. Now the whole reason why I did this setup is because I want to find, given some particular point that I know is on the plane and any other XYZ that is on the plane, I can construct a vector that is definitely on the plane. And we've done this before when we try to figure out what the equations of a plane are. A vector that's definitely on the plane is going to be the difference of these two vectors, and I'll do that in blue. So if you take the yellow vector minus the green vector, or take this position, or you will get the vector that, if you view it that way, that connects this point and that point, although you can shift the vector, but you'll get a vector that definitely lies along the plane, even if you start one of these points, it'll definitely lie along the plane. So the vector will look like this, and it would be lying along our plane. So this vector lies along our plane. That vector is P minus P1. This is the vector P minus P1. It's this position vector minus that position vector gives you this one. Or another way to view it is this green position vector plus this blue vector that sits on the plane will clearly equal this yellow vector, right? Heads to tails. It clearly equals it. And the whole reason why I did that is that we can now take the dot product between this blue thing and this magenta thing, and we've done it before, and they have to be equal to 0 because this lies on the plane. This is perpendicular to everything that sits on the plane, and it equals 0, and so we will get the equation for the plane. But before I do that, let me make sure we know what the components of this blue vector are. So P minus P1, that's the blue vector. You're just going to subtract each of the components. So it's going to be X minus XP. It's going to be X minus XPI plus Y minus YPJ minus YPJ plus Z minus ZPK. And we just said this is in the plane, and this is this, right, the normal vector is normal to the plane. You take their dot product is going to be equal to 0. So n dot this vector is going to be equal to 0, but it's also equal to this a times this expression. I'll do it right over here. So these, I'll find some good colors. So a times that, which is ax minus axp plus b times that, so that is plus by minus byp, and then make sure I have enough colors, and then it's going to be plus that times that, so that's plus cz minus czp, and all of this is equal to 0. Now what I'm going to do is I'm going to rewrite this so we have all of these terms. I'm looking for right color. We have all of the x terms. Ax, remember this is any x that's on the plane will satisfy this. So ax, by, and cz. Let me leave that on the right hand side. So we have ax plus by plus cz is equal to, and what I want to do is I'm going to subtract each of these from both sides. Or in other ways, I'm going to move them all over. Let me do it. Let me not do too many things. I'm going to move them over to the left-hand side. So I'm going to add positive AXP to both sides. That's the equivalent of subtracting negative AXP. So this is going to be positive AXP, and then we're going to have positive BYP plus, do that same green, plus BYP, and then finally plus CZP. Plus CZP is going to be equal to that. Now the whole reason why I did this, and I've done this in previous videos where we're trying to find the formula or we're trying to find the equation of a plane, is now I said, hey, if you have a normal vector and if you're given a point on the plane, where in this case it's x, p, y, p, z, p, we now have a very quick way of figuring out the equation. But I want to go the other way. I want you to be able to, if I were to give you a equation for a plane, where I would say ax plus by plus cz is equal to d. So this is the general equation for a plane. If I were to give you this, I want you to be able to figure out the normal vector very quickly. So how could you do that? Well, this ax plus by plus cz is completely analogous to this part right up over here. Let me rewrite this over here so it becomes clear. This part is ax plus by plus cz is equal to all of this stuff on the right-hand side. Sorry, on the left-hand side. So let me copy and paste it. Copy and paste it. So I just essentially flipped this expression. But now you see all of this A has to be this A has to be this A, this B has to be this B, this C has to be this thing, and then the D is all of this, and this is just going to be a number. This is just going to be a number, assuming that you knew what the normal vector is, what your A, B's, and C's are, and you know a particular value. So this is what D is. So this is how you can get the equation for a plane. Now, if I were to give you an equation for a plane, what is the normal vector? Well, we just saw it. The normal vector, this A corresponds to that A, this B corresponds to that B, that C corresponds to that C. The normal vector to this plane we started off with has the components A, B, and C. So if you're given an equation for a plane here, the normal vector to this plane right over here is going to be AI plus BJ plus CK. So it's a very easy thing to do. If I were to give you the equation of a plane, let me give you a particular example. If I were to tell you that I have some plane in 3 dimensions, let's say it's -3, although it'll work for more dimensions. Let's say I have -3x plus square root of 2y let me put it this way, minus, or let's say plus 7z is equal to pi. So you have this crazy, I mean, it's not crazy, it's just a plane in 3 dimensions. And I say, what is a normal vector to this plane? You literally can just pick out these coefficients. You say a normal vector to this plane is negative 3i plus square root of 2 plus 2 square root of 2j plus 7k, and you could ignore the d part there. And the reason why you can ignore that is that'll just shift the plane, but it won't fundamentally change how the plane is tilted. So a normal vector to this normal vector will also be normal if this was e, or if this was 100. It would be normal to all of those planes, because all those planes are just shifted, but they all have the same inclination, so they would all kind of point in the same direction, and so their normal vectors would point in the same direction. So hopefully you found that vaguely useful. We'll now build on this to find the distance between any point in 3 dimensions and some plane, the shortest distance that we can get to that plane.
Okay ပါပြီးတော့ပါပြီလားခင်ဗျာဒီဟာလေးကလေပြုံးကြီးနဲ့ကြည့်လိုက် plain ဆိုရင်အဲ့မျက်စိတွေမှာလဲဆိုတော့ image နဲ့ပတ်သက်တာရန် familiar ဖြစ်နေတော့ဒီဟာလေးကိုလေဒီဟိုရိုးကောင်းဆိုရင် image ပုံစံလေးမြင်လိုက်ရင်ဒီဟာလေးဒီလိုမျိုး x y z ပုံစံမျိုးဆွဲပုံစံမျက်စိတွေပြုံးနေစဉ်းစားမိသွားတာပေါ့နော်ခုနဟုတ်တယ်မသိအောင်တော့လေပေါ်လာတော့အဲ့တော့ဒီကပြောချင်တာဒီ unit j နဲ့ဒီ unit k ဒီဟာလေးက unit vector လေးပေါ့နော် unit vector မမိကြလားမသိဘူးဟိုဒီမှာဆို unit vector 10ဒီမှာ3ခုရှိတာဖြစ်တဲ့100ဒီမှာဆိုရင်သူ့ရဲ့အခန့်သူ unit vector လေးရေးတာပဲပေါ့မမိကြလားမသိဘူး2 dimension မှာဆိုရင်ဒီမှာဆိုရင်100ဒီမှာဆိုရင်010ဒီမှာဆိုရင်001ဆိုပြီးတော့လေ vector unit vector လေးရှိတယ်ပေါ့နော်ဒီဟာလေးကအဲ့လိုမျိုးလေးတဲ့ဟာလေးမျက်စိကြမြင်ရလားမသိဘူး2 dimension မှာသူရေးတာ001ဆိုပြီးတော့လေအဲ့ဒါကိုပြောချင်တာပေါ့နော်ဒီမှာ unit vector လေး
ဟုတ်ကဲ့
ဒီမှာဆိုသူအဓိကပြောချင်တာက Dallas တို့ဒီ plane နဲ့ပတ်သက်ပြီးတော့ပေါ့နော်ဒီ plane တစ်ခုကဒီလိုဒီဟာဆို unit vector ဖြစ်တယ်ဆိုရင်တို့နှစ်ခုရဲ့ဒီဟာဘယ်လိုရှာလဲပေါ့ဒီဟာလေးကအဲ့လဲဆိုဒီခုန dot product လုပ်တဲ့ဟာတန်ဘယ်လိုထွက်လာမလဲပါမယ်ဆိုအဲ့ဒါလေးကိုပြန်ပြီးရှင်းပြတာပေါ့နော်အဓိကဒီဟာလေးကိုအောက်မှာပြန်သုံးချမယ်ဆိုလို့ထင်ပါတယ်ကြည့်ရတာလို့ဆိုဒီဟာလေးကိုသူပြောပြတယ်ပေါ့နော်အဲ့ဒါဆိုခဏကြာရင် distance ရှာမှာဆိုတော့ဒီဟာကိုဘယ်လိုဟာမျိုးလဲမှတ်မိလားမသိဘူးဒီ quiz ဒီ machine learning for AI မှာ mathematics for machine learning ထဲမှာအဲ့ဆိုဒီshift direction တွဲပြီးသူတို့ညရဲ့ lower distance ကဘာဖြစ်လဲညာဖြစ်လဲဆိုတဲ့ဟာမျိုးရှာတာမျိုးပြောချင်တာဒါပြောချင်တာကိုယ့်ရဲ့ near me application တွေပါညာကြားဘူးလားမသိဘူးဒီ Google မှာရှိရလေ near me map တွေပါတယ်သိတာမသိဘူးအဲ့ဒီမှာဆိုကို short တစ်ခုသွားခြင်းနဲ့ကိုနဲ့နေတော့ဘယ်ဟာရှိလဲဆိုတဲ့ဟာမျိုးရှာတဲ့နေရာမှာသုံးတာမျိုးလေးဖြစ်နိုင်တယ်ပေါ့ကြည့်ရအောင်နောက်တစ်ခုနော်သွားခဏရလက်စပဲရောက်နေကြကြည့်အောင်အဲ့ဆိုရောက်နေတာကအခုလောလောဆယ်ဒီ point distance ပေါ့နော်ဒီနှစ်ခုပြအောင်လုပ်လိုက်မယ်ပေါ့ဒီနေ့ဒီဟာလေးဖြတ်လိုက်အောင်ပြီးတော့မှဒီနေ့ကဒါလေးဖြတ်ပြီးသွားရင်လည်းဆိုဒီ vector နဲ့ပတ်သက်တာပြီးသွားပြီပေါ့နော် matrix ပဲရောက်လာမှာဆိုတော့ကဒီနှစ်ခုအရင်ပြအောင်လုပ်လိုက်အောင်လို့ဒီနေ့ကနော်
What I want to do in this video is start with some point that's not on the plane, or maybe not necessarily on the plane. So let me draw a point right over here. And let's say the coordinates of that point are x not x sub 0, y sub 0, and z sub 0. Or it could be specified as a position vector. I could draw the position vector like this. So the position vector, let me draw better dotted lines. The position vector for this could be x naught I plus y naught j plus z naught k. It specifies this coordinate right over here. What I want to do is find the distance between this point and the plane. Obviously, there could be a lot of distance. I could find the distance between this point and that point, and this point and this point, and this point and this point. And when I say I want to find the distance, I want to find the minimum distance. And you're actually going to get the minimum distance when you go the perpendicular distance to the plane, or the normal distance to the plane. We'll hopefully see that visually as we try to figure out how to calculate the distance. So the first thing we can do is let's just construct a vector between this point that's off the plane and some point that's on the plane. We already have a point from the last video that's on the plane, this x sub p, y sub p, z sub p. So let's construct a vector here. Let's construct this orange vector that starts on the plane, its tail is on the plane, and it goes off the plane. I want to do that orange. It goes off the plane to this vector that's to this position x naught, y naught, z naught. So what would be how could we specify this vector right over here? Well, that vector, let me call that vector, well, I'll just call that vector, what letters have I not used yet? Let me call that vector f. Vector f is just going to be this yellow position vector minus this green position vector. So it's going to be this, each of these coordinates, this x component is going to be the difference of the x coordinates, its y coordinates is going to be the difference of the y coordinates, is going to be x naught minus x sub p. I subtracted the x coordinate I, plus y naught minus ypj, plus, go to the next line, plus z naught minus zp minus zpk. So fair enough. That's just some vector that comes off of the plane and onto this point. But what we want to find out is this distance. We want to find out this distance in yellow, the distance that if I were to take a normal off of the plane and go straight to the point, that's going to be the shortest distance. And actually you can see it visually now, because if you look at, we can actually form a right triangle here. So this base of the right triangle is along the plane. This side is normal to the plane, so this is a right angle. And you can see if I take any point, any other point on the plane, it will form a hypotenuse on a right triangle. And obviously the shortest side here, or the shortest way to get to the plane, is going to be this distance right here, as opposed to the hypotenuse. This side will always be shorter than that side. So given that we know this vector here, how can we figure out this length here? How can we figure out this length here in blue? Well, we could figure out the magnitude of this vector. So we could, the length of this side right here is going to be the magnitude of the vector. So it's going to be the magnitude of the vector f. That'll just give us this length, but we want this blue length. Well, we could think about it if this was some angle. I know the writing's getting small. If this was some angle theta, we could use some pretty straight up, pretty straightforward trigonometry. If the distance under question is d, you could say cosine of theta. We could say that cosine of theta is equal to the adjacent side over the hypotenuse, or is equal to d. D is the adjacent side, is equal to d over the hypotenuse. Well, the hypotenuse is the magnitude of this vector. It's the magnitude of the vector f. Or we could say the magnitude of the vector f times the cosine of theta. I'm just multiplying both sides times the magnitude of the vector x. F is equal to d. But that's still, you might say, okay, well, Sal, we know what z is. We know what f is. We could figure that out. We could figure out its magnitude, but we don't know what theta is. How do we figure out what theta? And to do that, let's just think about it a little bit. This angle theta is the same angle, so we don't, this distance here isn't necessarily the same as the length of the normal vector, but it's definitely going in the same direction. So this angle here is really the same thing as the angle between this vector and the normal vector. And so you might remember from earlier linear algebra, when we talk about the dot products of two vectors, it involves something with the cosine of the angle between them. And to make that fresh in your mind, let's multiply and divide both sides. Let me multiply and divide the left side of this equation by the magnitude of the normal vector. So I'm obviously not changing its value. I'm multiplying and dividing by the same number. So I'm going to multiply by the magnitude of the normal vector, and I'm going to divide by the magnitude of the normal vector. So I mean, I'm just essentially multiplying by 1, so I have not changed this. But when you do it in this, it might ring a bell. This expression up here, this expression right here, is the dot product of the normal vector and this vector right here, f. So this right here is the dot product. This is n dot f up there. It's equal to the product of their magnitudes times the cosine of the angle between them. So the distance, that shortest distance we care about, is a dot product between this vector, the normal vector, divided by the magnitude of the normal, magnitude of the normal vector. So let's do that. Let's take the dot product between the normal and this. And we already figured out in the last video, the normal vector. If you have the equation of a plane, the normal vector is literally, its components are just the coefficients on the x, y, and z terms. So this is a normal vector right over here. So let's literally take the dot product. So n dot f is going to be equal to a times x naught minus xp. So it's going to be equal to, I'll do that in pink. So it'll be a x naught minus AXP, and then plus B times the Y component here. So plus BY, I'm just distributing the B, minus BYP, and then plus, do another color here, this C, is too close of a color, plus C times the Z component. So plus C Z naught minus C ZP, and all of that over the magnitude of the normal vector. So what's the magnitude of the normal vector going to be? It's just the square root of the normal vector dotted with itself. So it's just each of these guys squared, added to themselves, and you're taking the square root. So it's the square root, yeah, I can do a nicer looking radical sign than that. It's the square root of A squared plus B squared plus C squared. Now, what does this up here simplify to? Let me just rewrite this. So this is the distance in question. This right here is equal to the distance, but let's see if we can simplify it. So first we can take all of the terms with the x naught. These involve the point that sits off the plane. Remember, x naught, y naught, z naught sat off the plane. So this is a x naught plus b y naught plus c z naught. And then what are these terms equal to? What are these terms of AXP, negative AXP minus BYP minus CZP? Well, if you remember here, D in the equation of a plane, D, when we started in the last video, when we tried to figure out what the normal to a plane is, D is, if this point XP sits on the plane, D is AXP plus BYP plus BYP plus CZP. Or another way you could say it is negative D. Negative D would be negative A, and it's just the difference between lowercase and uppercase here, right? We say that lowercase a is the same as this uppercase a. So it's negative A XP minus BYP minus CZP. I'm just using what we got from the last video. This is what D is, so negative D will be this business. And that's exactly what we have over here. Negative AXP, negative BYP, negative CZP. So all of this term, and this term simplifies to a minus D. And remember, this negative capital D, this is the D from the equation of the plane, not the D, not the distance D. So this is the numerator of our distance. And then the denominator of distance is just the square root of A squared plus B squared plus C squared. And we're done. This tells us the distance between any point and a plane. And this is a pretty intuitive formula here, because all we're doing, if I give you an example. Let's say I have the plane. If I have the plane 1x minus 2y plus 3z is equal to 5. So that's some plane. And let me pick some point that's not on the plane. So let's say I have the point, I don't know, let me say I have the point 2, 3. Let me make sure it's not on the plane. So it's 2 minus 6 is negative, yes, this one. Let me just pick a random 1. So this definitely is not on the plane, because we have 2 minus 6 plus 3, that gives us negative 1, which is not 5. So this is definitely not on the plane. We can find the distance between this point and the plane using the formula we just derived. We literally just evaluate it at, so this will just be 1 times 2, 1 times, use that same color, 1 times 2 minus 2 times, I'm going to fill it in, plus 3 times something minus 5, all of that over, and I haven't put these guys in, let me do that right now. So 1 times 2 minus 2 times 3 plus 3 times 1, this one, minus 5, kind of bringing it over to the left-hand side, all of that over the square root of 1 squared, which is 1, plus negative 2 squared, which is 4, plus 3 squared, which is 9. So it's going to be equal to, let's see, this is 2 minus 6, or negative 6, and then you have plus 3, and then minus 5. So this is what? This is 5 2 plus 3 is 5 minus 5, so those cancel out. So this is negative 6. So it's equal to negative 6 over the square root of 5 plus 9 is 14, over the square root of 14. And you're done. So hopefully you find that useful, and hopefully we can apply this in other example problems.
Hey, formula လေးကိုဘယ်သူမှမကြသေးလဲ
What I want to
ဒီ formula လေးကိုလည်းလဲဆိုရင်တွား this point ကိုရှာတော့အကုန်တွားကြရတယ်ဖက်ခွေးဝမ်းပါလေမမိကြလားဘယ်သူမှမိလဲဒီဟာလေးလေဒီပုံစံမျိုးလေးမမိတရက်လောက်မမိလားမိကုန်သွားပြီလားအဲ့မဲ့ဆိုဒီဟာဆိုဒီ point ကိုဒီသူဒီမှာပြောရတဲ့အရာဆိုရင်ပေါ့နော်အဲ့လဲဆိုသိချင်တာကအမှန်နဲ့ဒီ plane မှာရှိတဲ့ဟာတော့ရှားရတာတော့ကိုမှရှိပြီဟုတ်ပြီဒီလိုဒီ point တစ်ခုကဒါ plane ထဲမှာမရှိဘူး outside မှာ out the plane မှာဖြစ်တယ်ဆိုဘယ်လိုများဖြစ်မလဲဘယ်လိုမှရှာမလဲဆိုတဲ့အကြောင်းသူကဒီ unit vector ကိုထပ်တုံးပြီးတော့ရှာရတဲ့သဘောလေးကိုပြောချင်တာပေါ့နော် trade တော့မဟုတ် unit vector လေးဆိုပဲ formula တွက်လိုက်တယ်ထားပါတော့ formula ထွက်လာတယ်ပေါ့နော်အဲ့ဒါ trade machine တော့ဒီအဲ့လိုမျိုးလုပ်လိုက်တယ်အဲ့လိုမျိုးလည်းဘယ်လိုနည်းတွက်လို့ရလဲဆိုခုနကသူပြောတဲ့ဒီမျိုးနည်းနဲ့တွက်လို့ရတယ်ဒီ formula လေးထွက်လာတယ်ပဲအကုန်သွားလိုက်တယ်ပေါ့နော်ဒီဟာလေးတော့အသေးသေးမပြောတော့ဒီ formula လေးထွက်လာတဲ့ခါကျရင်ဒီလိုမျိုးလေးတွက်လို့ရတယ်ဆိုတဲ့အကြောင်းလေးသူပြောပြသွားတယ်ပေါ့နော်ဒီ point ကိုရှာတဲ့နေရာမှာကိုကကို plane ထဲမှာမရှိနေအောင်မှာတခြားနေရာမှာဒီလိုမျိုး formula သုံးပြီးရှာလို့ရတဲ့သဘောလေးပေါ့နော်ဟုတ်ပါပြီနောက်တစ်ခုသွားကြည့်အောင်ဒီဟာလေးပတ်သက်ပြီးနည်းနည်းဘယ်လိုမှနည်းနည်းတော့ရှုပ်သလားရိုင်းတော့မချင်းပေါ့နော်ဗီဒီယိုဗာမြင်အနည်းဆုံးဒီ formula လေးတော့မရှိတယ်နည်းနည်းရင်းနှီးကြမယ်ထင်ပါတယ်ဒီမှာ square root ရှာရတယ်ဒီမှာဆိုရင်တော့ dot product ရှာတဲ့ဟာလေးလေဟုတ်ပါနောက်တစ်ခုပဲကျန်မှာတော့လေဟုတ်ဘူးဒီနောက်ခုကလုံးဝအရင်မကြပါသေးနဲ့ဒါ point ကိုရှာခုန point ကိုရှာဒါ distance ပေါ့နော် point နဲ့ distance okay ခုန point ကိုရှာတဲ့ဟာကိုရှာတယ်ခုန point ကလည်း distance ကိုရှာရမှာမဟုတ်လား point distance ကိုရှာတယ်ပေါ့နော်ဒီဟာနဲ့ဘာကွာလဲတော့မသိဘူးပေါ့ distance between plane နဲ့ point distance between plane so let's see distance between planes so
if the distance between the plane ax minus 2y plus z equals d and the plane containing the lines, and they give us two lines here in 3 dimensions, if that distance is square root of 6, then the absolute value of d is. So let's think about it a little bit. They're talking about the distance between this plane and some plane that contains these two lines. So in order to talk realistically about distances between planes, those planes will have to be parallel, because if they're not parallel, if they intersect with each other, the distance is clearly 0. And they're telling us here that the distance is the square root of 6. So we have a situation so that the planes can't intersect, they must be parallel. So you have this plane up here, you have this plane up here, we could call this. The equation here is ax minus 2y plus z is equal to d. And then you're going to have another plane that's going to be parallel to it. Maybe it looks something like this. You have the other plane that is parallel, and it's going to contain both of these lines. So maybe it has this line. So this line is in, I'll say it in green. Maybe this line looks something like this. It's on that blue plane. And then this line, maybe in magenta, is also going to be on the blue plane. So how can we figure out the distances? Well, a good starting point would be to try to figure out the equation for this blue plane here. And since these planes are parallel, this equation should look very much like this orange equation, at least on the left-hand side. It might just have a different d value. That's because it has the exact same inclination. And then once we figure out the equation for this plane over here, then we could actually probably figure out what A is. Then we could find some point. On the blue plane, and then use our knowledge of finding the distance between points and planes to figure out the actual distance from any point to this orange plane. So let's figure out the equation of this blue plane first. And a good place to start is just to try to figure out two vectors on this blue plane. Then we can take the cross product of those two vectors to find out a normal to the blue plane, and then use that information to actually figure out the equation for the blue plane. So let's figure out first some points that sit on the blue plane. So on this green line right over here, you have, see, if I want all of these to be equal to 0, you'd have the point x is equal to 1, y is equal to 2, z is equal to 3. So you'd have the point 1, 1, 2, 3. That definitely sits on the blue plane. Let's come up with another point. Let's see, if I want all of these to be equal to 1, I could make this, if I want this to evaluate to 2, I would have the point 3. I would have the point, if I want this to evaluate to 1, I would want 5 minus 2 over 3, so 3, 5. and then I would want this to be 7. 7 minus 3 over 4 is also 1. So that's another point. Actually, both of these points sit on this line right over here. 1, 2, 3, and then 3, 5, and 7. And then let's do the same thing for this. Let's find 2 points on this plane. Actually, we just have to find 1 point on this plane, because if you have 3 points, that's enough to figure out 2 different vectors that aren't scalar multiples of each other, which would be enough to figure out the normal to this plane. So let's just figure out 1 more point over here, and 1 more point would be, if we want all of these 3 to be equal to 0, would be the point 2, 3, 4. 2, 2, 3, 4, because this would be 0, 0, 0. So that's also sitting on the plane, and that sits on the magenta line right over there. So let's use these 3 points to figure out 2 vectors on the plane that aren't multiples of each other. Then we can take their cross product to actually figure out a normal vector to the blue plane. So let's say the first vector, A, that sits on this plane, let's say it's the difference in the position vectors that specify these 2 points. And we know that'll be on the plane. And so that will be 3 minus 1 is 2i, plus 5 minus 2 is 3j, plus 7 minus 3 is 4k. So vector A is actually going to sit on this green line, because both of these points are on this line. So it's going to sit on that line. If we put it on the plane, or if we were to start it at one of those points, it will sit on that line. And then we could do another vector, and it's essentially going between a point on the green line and a point on the purple line, but that's definitely going to be a vector on our blue plane. And let's go between these 2 points. That looks pretty straightforward. So let's call vector B. Let me do another color so we don't confuse ourselves with that purple. Let's call vector B. Let's call that, let's see, 2 minus 1 is I, 3 minus 2 is J, and then 4 minus 3, that's just 1K. So this vector right here is also sitting on the plane. So if I take the cross product of A and B, I am going to get a vector that is perpendicular to the plane, or a normal vector to the plane. So let's do that. So let's find what A cross B is. A cross B is equal to, and this is how I find it easiest, I just write I, J, K. This is really the definition of the cross product, or I guess one of them. And we write our first vector. We have 2, 3, 4, and then we have our second vector, which is just 1, 1, 1, and then this is going to be equal to, first we'll look at the I component, so cross that row, that column out, 3 times 1 minus 1 times 4, so that's just 3 minus 4, so it's negative I, and then minus, we're going to have the J, so let me write a minus here, minus, we just swap signs, we have positive, negative, positive, so J, get rid of that column, that row, 2 times 1, which is 2, minus 1 times 4, so that's minus 4 is negative 2, so we could write a negative 2 here, but the negatives cancel out, so it becomes plus 2J, and then finally for the K, get rid of that row, that column, 2 times 1 is 2, minus 1 times 3 is 2 minus 3, which is negative 1, so it's negative K. So this right here is a normal vector. This right here is a normal vector, is a normal the equation for that plane. We've done it multiple times. We just have to take the dot product of that normal vector. We just have to take the dot product of that normal vector and any arbitrary vector on that that's specified, that we can specify with an arbitrary x, y, and z. And we've done this multiple times in multiple videos. If this is any point x, y, z that sits on the plane, so this is any point x, y, z that sits on a plane, then the vector, let me draw the vector, let's say we go to this point right over here. So this vector right over here is going to be, let me draw it the other way actually. So this vector right over here, let's say we're going between this point and x, y, z. This vector right here is going to be x minus 3i plus y minus 5j plus z minus 7k. That's what this vector is. It sits on the plane, assuming x, y, and z sit on the plane. So if we take the dot product of this and the normal vector that has got to be equal to 0 because it sits on the plane, and then we'll have our equation. So let's take n dot that over there. So n dot x minus 3I plus y minus 5j plus z minus 7k. If any of this is confusing to you, I've gone into a little bit more depth in previous videos, especially in the linear algebra playlist, where I talk about constructing the equation of a plane, given a point on the plane and the normal vector, and even how do you find that normal vector. So you might want to watch those if you want some review there. But these are going to be equal to 0. So when you take the dot product, and our normal vector is this. So we just take the x term, which is -1, times this x term right over here. So -1 times this is just 3 minus x, and then plus this y component times this y component. So it's 2 times this, so it's plus 2y minus 10. And then finally the z component, -1 times this. So this is plus 7. Plus 7 minus z is equal to 0. And what do we get? So we have our negative x plus 2i minus z, and then is equal to, let's subtract 3 from both sides. So if we take it out there, it'll be minus 3. If we add 10 to both sides, so then you have a plus 10 over here, and then we subtract 7 from both sides. This becomes a minus 7. So then on the right-hand side, -3 plus 10 minus 7, well, that's just going to be 0. That's just going to be 0. And just like that, we have the equation. We have the equation for this blue plane over here, the plane that contains these two lines. Now remember what we said at the beginning of the video. These two planes are parallel. So the ratio of the coefficients on the x terms, the y term, and the z term has got to be the same. And so this one has a +2, that has a -2. This is just to simplify it so it looks very similar to each other. Let's multiply this equation right here, both sides, by -1. And then we're going to get x minus 2y plus z is equal to 0. So this is a completely valid, another alternate way of expressing the same plane. And what I like about this is it looks very similar to this, at least the ratios of the x, y's, and z's. -2y, -2y, 1z, 1z. And remember, the ratios have to be the same. So here we have a 1-to-1 ratio between the z coefficient and the z coefficient, the y coefficient and the y coefficient. So it's also going to be for the x coefficient. So here we know if this is going to be parallel to the blue plane, we know that a has got to be equal to 1. So this is x minus 2y plus z is equal to d. So now let's figure out the actual distance. Let's actually figure out the actual distance between these two planes. So what we can do is we can take a point on this blue plane, and we have several examples of points on the blue plane, and find the distance between that point and this plane over here. And actually, I just finished doing some videos on how do you find the distance between a point and a plane. So I'm just going to use that formula. If you want it to be proved, go watch that video. It's actually a pretty interesting proof, I think. But the distance between, let's say, this point, 1, 2, 3, and this plane over here, and this plane. So this distance right here is going to be in the direction of the normal. The distance is going to be, I want to be careful not using that. So I'll actually write out the word. Don't want to overload variables. The distance is going to be, you literally just evaluate this. Let me do it this way. You literally put in this point for the x, y, and z, and then you subtract the d in the numerator. We saw that as the formula for finding the distance. So it's literally going to be 1. I'm actually using this point right over here. It's going to be 1, because we just have 1x, so it's just going to be 1 minus 2 times 2, 1 minus 4, that's 2 times 2, plus 3, minus d. Well, here, the d is just d, so we're just going to write minus d, just like that. All of that over what is essentially the magnitude of the normal vector, and we saw in several videos, that's just the square of the coefficients on each of these terms right here, and taking the sum of those, taking the square root. So it's going to be equal to 1 squared plus -2 squared, which is 4, plus 1 squared, which is 1. So this is going to simplify to the distance is equal to 1 minus 4 plus 3 is 0. So in the numerator we have negative d, all of that over the square root of 1 plus 4 plus 1. So all over the square root of 6. So they say the distance, if the distance between the plane ax minus 2y plus z is equal, between this plane and this plane over here, is square root of 6. So they're saying the distance is equal to the square root of 6. That's what this information right over here is. Maybe I should do that in another color. So this distance right, that's not another color. The distance between the two planes is going to be the square root of 6. And so then if we solve for d, multiply both sides of this equation times the square root of 6, you get 6 is equal to negative d, or d is equal to negative 6. Now, what they care about is the absolute value of d, or the absolute distance. And that's actually, this would be kind of the signed distance. It kind of specifies whether we're above or below the plane. Below the plane, we got a negative number. I just happened to draw it right. If we were above the plane, we would get a positive number. So this distance is negative 6, the absolute value of it. The absolute value of d, which is the same thing as the absolute value of negative 6, is equal to 6. So take any point on this blue plane, and you look for the closest point on the orange plane, and they will be exactly 6 apart. Anyway, hopefully you found that interesting.
ဒါဒီ video လည်းဆို interesting တော့လုံးဝမရှိဘူးပေါ့နော်စိတ်နားထောင်တာစိတ်မပါဘူးအမှန်တိုင်းပြောရရင် okay ဗျာဒီဟာကြီးတော့အရင်တော့ကောင်းမချုပ်တော့လည်းစိတ်ပြီးတော့ discussion မလုပ်ချင်တော့ဒီဟာလေးကအရင်လည်းမဆိုင်လို့ပဲလည်းမြင်မိလိုက်တယ်ပေါ့နော်နောက်ပိုင်းကျမှကိုတကယ်လို့ deep သွားခြင်းနဲ့သွားပေါ့နည်းနည်းကောင်းလေးရှုပ်သွားသူကနားထောင်သူကစိတ်ကတခြားစီရောက်သွားတဲ့အဆင့်တောင်ရောက်တယ်ဆိုတော့ကဟုတ်ပါဒီနေ့တွေကအဲ့ဆိုတွေ better နဲ့ပတ်သက်ပြီးတော့ဒီ summarize တွေကိုပြန်ကြည့်မယ်ဆိုရင်အဲ့ဆိုဘာသတိထားမိလဲ dot နဲ့ crop product ကိုဒါလေးမရှိမြင်ကြမယ်ထင်တယ်ပေါ့နော်တော့များနည်းကြာနေပြီဆိုတချို့ဟာလေးဆိုမျက်စိကမေ့အောင်မေ့သူပြောတဲ့ဟာလေးကိုငါနောက်ထောက်ပွားရလားဆိုတဲ့ဟာဖြစ်တယ်။မောင်လေးညီမလေးတို့ဘယ်လိုဖြစ်လဲမသိအဲ့လိုလေးဖြစ်သွားတယ်ပေါ့နော်ခုနကဒီဟာကိုသူပြောသွားရလားငါဘယ်ကနားထောင်လိုက်လဲအဲ့လိုမျိုးပြန်မေးတယ်ပေါ့နော်ဒီမှာဆိုတော်တော်များကိုရလောက်တာပဲမေ့ကုန်ပြီပေါ့နော်ဆိုတော့ anyhow အဲ့ဆိုဒီဟာလေးကိုပြီးသွားပြီဆိုတော့နောက်အပတ်ကျရင်လည်းဆို metric နဲ့ပတ်သက်တာသွားကြမယ်ပေါ့နော်ဒီဟာ better နဲ့ပတ်သက်တာဒီ distance ရှာတဲ့ဟာလေးရဲ့ dot product ရဲ့ cross product ရဲ့အဲ့ဒါလေးအုံနောက်တွေကြံနေတယ်ပေါ့နော်နောက်တစ်ခုကဒီ better နဲ့ဆိုင်ပြီးတော့ magnitude ပေါ့နော် magnitude ကဘာလို့ပြောတာလဲပြီးရင် same direction သွားတာတော့ opposite direction သွားတာတော့ short distance ရှာတာတော့အဲ့ဒါမျိုးလေးရှိတယ်ဆိုတဲ့အကြောင်းလေးအုံနောက်တွေမှာကြံခဲ့ပေါ့နော်ပြီးရင် dot product က scalar ထွက်တာတော့ cross product က better ထွက်တာတော့အဲ့ဒါမျိုးလေးလည်းမျက်စိအုံနောက်တွေကြံခဲ့စေချင်တယ်ပေါ့နော်ဒီဟာ formula မြင်ရတာက different ထားပေါ့နော်ပြီးတော့သူ့ properties လေးပေါ့နော် orthogonal တို့ perpendicularity တို့ပြီးရင် dot product က a 0ဖြစ်သွားရင်ဘာဖြစ်တယ်ဆိုတဲ့ဟာမျိုးလေးတို့အဲ့ဒါလေးပေါ့နော်အကြမ်းချင်းခဲ့ရတော့ဒီ dot product က0ခုနက cosine တို့ sin theta 1တို့အဲ့ဒါမျိုးလေးပေါ့နည်းနည်းအုံနောက်တွေမှာရှိသေးချင်ပါတယ်လို့ဒီဟာလေးအချိန်ပေးတာဖြစ်တော့တက်နော်။ဟောလို့ညီမလေးရောတခြားဘာပြောစရာရှိသေးလဲ။ဒီဟာလည်းဆိုဒါ elimination process ကိုသွားကြမယ်တဲ့ echelon form bat နဲ့ပတ်သက်တာတဲ့ဒါ echelon ပါဒီဟာလေးကတော့ပါ metric product no okay ဒီဟာလေးပဲအဓိကကျန်တော့တာပေါ့နော်ဒီဟာလေးကြံပြောရင်ဟို post ဆိုပြန်ပြီးတော့ပြန်လဲကြည့်ကြတာပေါ့ဒီဟာလေးကဘာမှမသိဒီ basis column ပြီးတော့ဒါလေးခဏထားအောင်မယ်ပေါ့နော်အဲ့ဒါလေးခဏထားတာအမေကဒီဟာလေးပြန်လုပ်မယ်ပြီးရင်လည်းဆို mathematics ပေါ် machine learning ကိုပြန်ပြီးတော့သွားကလိကြတာပေါ့နော်အဲ့ဒါပထမပိုင်းမှရှိသေးတယ်ကျန်တဲ့အများကြီးကျန်သေးတယ်မဟုတ်ဘူးလားအဲ့မအောင်ဆိုဒါက better space unit ပဲရှိသေးတယ် sorry ရလား metric နဲ့ better space unit ပဲရှိသေးတယ်ပေါ့နော်အဲ့ဒီမှာတော့ဒါတစ်ခုကျန်သေးတယ်ဟိုဒီအဲ့ဒါကလုံးပြီးသွားပြီထင်တာဘယ်ရလားအခုမှဒါ session 1ပဲရှိသေးတာပဲ metric တောင်မရောက်သေးဘူးပေါ့နော်ကဲဒီဟာလေးပြီးသွားရင်ဒီမှာ metric နဲ့ပတ်သက်တာလာပြီပေါ့နော်ဟုတ်ပါပြီနောက်တစ်ခု LS ပြောချင်တာဒီဟာလေးကိုမောင်လေးဖြစ်နိုင်ဒီမှာလေးသွားကြည့်ကြပါဒီ better explain လေးဖတ်ကြည့်အားရင်ဝင်ဖတ်ကြည့်ပေါ့နော်သင်္ချာနဲ့ပတ်သက်တာဒီဟာလေးအရင်လေးချွတ် LS ကဒီကသင်္ချာနဲ့ပတ်သက်လာရင်ကပြောချင်တာပေါ့နော် intuition ကိုအုံနောက်ထဲမှတ်ပါပေါ့နော် intuition ကိုပဲမှတ်ပါလုံးဝသင်္ချာ formula လေးခါ summarize မှတ်မိကြမှာဒီကဒီဟာကိုဘာဖြစ်လို့ငါလေးလာနေလဲပေါ့နော်သူ့ရဲ့ဟိုသင်္ချာလေးလည်းသိတဲ့အတိုင်း10တန်း9တန်း10တန်းငယ်လေးကအခုချိန်ကြီးလုံးနေရတော့မယ်သိတယ်မလားအပင်နေရာမှာဘာကြောင့်သုံးလဲ real life application မှာဘယ်လိုသုံးနေလဲဘာကြောင့်သုံးလဲဘယ်လိုအကျိုးရှိလို့သုံးလဲအဲ့ဒါလေးကိုအဓိကဦးစားပေးလေးလာသေးတယ်ပေါ့နော်ဒီတိုင်းတချို့ဒီတိုင်းပေါ့နော် number တွေ formula တွေအဲ့လောက်ကောင်းမချုံနဲ့ number တွေ formula တွေအများကြီးရှိတယ်သိရမလားဒီဟာမျိုးတစ်ခုအခု better တွေနှစ်ခုမှ depend လုပ်လိုက်တော့ dot product ဖြစ်သွားငါတို့ဘာဖြစ်နေမှာဘယ်လိုသုံးချလို့ရအဲ့လိုမျိုးဟာလေးတွေကိုအုံနောက်တွေမှာတွေးစေချင်တယ်ပေါ့နော် thinking process လေးကိုနည်းနည်းရှိသေးတယ်ပေါ့။ခါကျကိုမသိတဲ့ဟာကျလိုက်ရှာဖတ်တဲ့အကျင့်လေးပဲလုပ်စေချင်တယ်ပေါ့နော်။အဓိက စိတ်ထဲမှာဖြစ်စေချင်တာက intuition ကိုလိုက်ရှာပေါ့တိလား formula တွေဘယ်လိုတွက်ရလဲ how ကိုက how to calculate ကလွယ်ကွာ why ဆိုတဲ့ question ပေါ့နော်ဘာကြောင့်လဲဆိုတဲ့ဟာမျိုးနည်းနည်းစဉ်းစားစေချင်ပါတယ်လို့ဟုတ်ပြီတစ်ခါကြာရင်ကွာအဲ့လိုမျိုးလေးနဲ့ပတ်သက်တဲ့ဟာလေးဘယ်လို intuition နဲ့ပတ်သက်တဲ့ဟာမျိုးလေးပဲနည်းနည်းစလုပ်ပါလို့မှတ်နည်းနည်းရှာကြည့်ပါလို့နော်ရှာကြည့်ပြီးလိုက်ဖတ်တာဖြစ်ပါဖြစ်ပေါ့နော်အဲ့လိုမျိုးလေးလုပ်ပါလို့နော်ဒီပါပြီးရင်ဒီဟာလေးတစ်ချက်ဝင်ကြည့်ပါလို့နော်စိတ်ဝင်စားရင်နော်မောင်လေးညီမလေးတို့ဒီအဲ့ဒါလေး stock ကို recording stock ရလိုက်ပါတော့မယ်လို့အားလုံးဒီနေ့တော့လောက်ပါပဲလို့